All right, welcome everybody. This is Noah, and in this video, we're going to look at the definition of the vertex form for a quadratic function, and we're going to do some GeoGebra explanation with that. Tripping my tongue up in the first few seconds of the video. All right, let's take a look here. So let's just start with the definition. The vertex form of a quadratic function is f of x equals a times x minus h quantity squared plus k. So what we want to do to play with this is we're going to put it into GeoGebra and just see what this vertex form looks like and how the a, the h, and the k values affect the shape of the graph. So what I'm going to do is I want to start by creating these sliders, a, h, and k. We're going to set a equal to 1. We're going to set h equal to 0, and we're going to set k equal to 0. And then I'm going to go ahead and type in the function f of x equals a times x minus h to the second plus k. And it shows us like if h and k are both 0, then those go away, a is 1. So this is essentially just y equals x squared when our sliders are set up in this manner. All right, so let me pull this up just a hair here. There we go, now we can see everything. All right, so we see that this is just our standard parabola, and let's see what happens if I just move a around. If I make a bigger, it looks, the eyes are actually a little deceiving here. Whoa, everything just went negative there. That's cool, so now it's going down more. So the key here is that it looks like it's maybe stretching it sideways, and that's not the case. It's actually stretching it up, or when it goes negative down. So watch this. Let's take a look at, let's go to 1 again. The point 1, 1 right here. And if I switch a to 2, we're going to watch this point go up. And similarly, this point will go up to 4. So here y value is 2. And it's going to go up to 4. This y value is 2, it's going to go up to 4. This y value is 1, it's going to go up to 2. This y value is 1/2, it's going to go up to 1. So let's go ahead and push this up to 2. So we see that this a value is actually stretching the graph vertically. And if I go this way, it's cutting those y values smaller and smaller. So the y values are getting cut down. If a is 0, all the y values are 0. And then as that goes negative, it flips the thing upside down and it makes the y values negative and then stretches the y values more and more down. So if this was a -1, well, let's do -1/2. There we go. So I can see this point right here, and it's going to go to here. So we're going to look for that point as I go to -1. Right, so I went from -1/2 to 1, so that doubled the y values. And if I go to 2 now, we can watch this point, and it should go to -2. If I go from -1 to -2 there. So there you go. All right, so we'll write that down. A stretches the parabola vertically. A negative a value will make the parabola go down. Or I should say, flip upside down. So it's downward facing. Right? If it's a positive a value, it's upward facing. All right, let's check out what happens when we move the h and the k values around. If we make h bigger, oh, it shifts it to the right. So if h is 1, let's just look at the vertex right there, that point. it's now shifted from the origin to the point 1, 0. It shifted it right 1. And as I keep moving it to the right, it's now at 2 when h is 2. It's at 3 when h is 3, and so on. If I go to the left, it shifts it into, if h is -2, then the vertex is at -2, 0. So h shifts the graph, shifts the parabola left and right. We do want to note that this is a minus h in the form that we put. And so that means if h is negative, it shifts it to the left. How do I put this? If I had x minus 3 in there, that would shift it to the right 3. If I had x plus 3 in there, that would shift it to the left 3. So the h is that negative right there means that when h is negative, that becomes a plus. And if h is positive, then we get x minus a positive h, like that. So it's going to look a little backwards, and we'll see that in the examples below here a little bit more carefully. The k value is a little bit easier. It's a plus k in the form. If I make k bigger, it shifts the graph up. And if I make k smaller, it shifts the graph down. So k shifts the graph, the parabola, up and down. Give myself just a hair more room here. So what we're going to notice is where the vertex is. So if the vertex, let's just move this to some whole numbers. There. H is -2, k is 1. Then the vertex is at the point -2, 1. If h is -3 and k is, we'll say, oops. I don't want to go too low and push it off the screen, -2, then the vertex is at -3, -2. So the point h comma k is the vertex. And that's why this is called the vertex form, because we can quickly see the vertex when we just look at the function. So let's take a look at the following functions. We will go ahead and graph these and see how they look on the graph. But let's take a moment to just see if we can figure out the answers to these questions without looking at the graph. So my function, f of x equals 8 times the quantity x minus 7 squared minus 8. So this minus 7, the h equals positive 7. Okay, the h is, it's x minus h. So h is a positive 7. And k is a minus 8, because the original expression was x minus h squared plus k. So the plus k means the minus 8 is the k. So k equals -8. Essentially, you could think of, for the inside of the square, this is the inside of the square. Then we get the h value, and it's the opposite sign. So if it's an x minus 7, then h is positive 7. But outside the square, you get the k value, and that stays what it is. So we can say h value is opposite sign, and the k value is the same sign. So let's go through the questions here. The x shift is going to be right 7, because that's just the h value, right? 7. The y shift is going to be down 8 because of the minus 8 there. The vertex is going to be the point 7 comma negative 8, right? We've moved right 7 and down 8. The y stretch is the a value. So the y stretch equals 8. That's a positive value, so it opens up since a is positive. And next question, the domain. So if I think about the domain, the only time that we have a domain restriction is if we have a square root, because we can't square root negatives, or if we have a denominator, because I can't divide by 0. But if I have something minus 7, I can take 7 from anything. I can square anything after that. I can multiply any number by 8, and I can subtract 8 from any number. So in the order of operations, there's no number here that we wouldn't be able to plug in. So the domain is all real numbers, negative infinity to infinity. And then the range is going to be a little bit more, we got to think about it a little bit more. And we're going to use the vertex and the fact that it opens up. So we know it opens up, and we know that this point, the vertex, is 7 comma negative 8. So that means that the range is the y value there, negative 8. Oops, right range. Range equals negative 8, inclusive, because we do have that point, and then it goes up for forever all the way to infinity. So we can say the range starts at the bottom, goes all the way up to the top. All right, and then finally we are looking at part 8, where it says what's the maximum or minimum y value. Fits better there. Cool. So last one. So with the parabola having this shape here, where it's upward facing, it has a minimum y value. So minimum y value, the smallest y value. It doesn't have a maximum y value because it keeps going up for forever. But the minimum y value is negative 8. Cool. It's not so bad, right? Let's go ahead and confirm that with Geogebra real quick. If we go ahead and make a equal to 8, I think I need my sliders a little bigger here. We can just type it in. A equals 8. And then h equals positive 7. And then k equals negative 8. Then we get our vertex down there at 7 comma negative 8, and it's upward facing, just like that. All right, let's go back and try the second one. Now we have g of x equals negative 2 times x plus 3 squared plus 5. First thing we're asked for, let's just identify again that this is h. H equals negative 3, right? It's always the opposite sign of the inside. And k is positive 5. Right? That k value is the same sign. The h value inside there is the opposite sign. All right. So this is going to go left 3 because h is negative. And it's going to go up 5 since k is positive. So the vertex is going to be at negative 3, 5, the h and k values. The y stretch is the a value. And because it's negative, it opens down. Since a is negative. All right, again, for a parabola, for a quadratic function, there is no domain restriction. So the domain is all real numbers, negative infinity to infinity. The range is going to equal, okay, this opens down, and the vertex is at negative 3, 5. So the range is everything up to positive 5. So from negative infinity up to positive 5, and we can include that 5 value. So this has a maximum y value. It does not have a minimum because it keeps going down for forever. Maximum y value equals 5. Cool. And let's go ahead and just check this in Geogebra. We'll go ahead and make the a value negative 2. The h is going to be negative 3 now. And the k value is positive 5. Move this over. So we can see that the vertex is at negative 3, 5. It's downward facing. Its maximum y value is 5. That's the range and everything. So yeah, cool. We have confirmed that now. All right. That's going to be it for this video, everyone. I'm going to zoom out so we can see all of this. Go ahead and give the Now You Try problems a shot, and in the next video, we'll run through those solutions. Thanks so much for watching. We'll see you in the next one.